Hi friends, welcome to the class of Design and Analysis of Algorithms. Now we are going to the topic of Quicksort. So Quicksort is one sort of a sorting method where you can arrange the elements in a sorted order. So which follows the concept of divide and conquer. In the previous class we have seen merge sort. Similarly here also Quicksort, it follows the concept of divide and conquer approach. Here we can see it is another divide and conquer approach that can be used to arrive at an efficient sorting method different from merge sort. So the method is different, of course both are efficient ones, and anyway we'll see the complexity difference between merge sort and quicksort in the later classes, but this is also one of the divide and conquer approach similar to merge sort. Now before going to this theory part, first I want to explain this quicksort with an example. So I have a number of elements here, that is 10 number of elements, and I want to arrange these elements in sorted order by using the concept of quicksort. How we can arrange, we will see. That is a algorithmic outline I want to explain here. How quicksort algorithm works, I will explain with this example. Okay. So first of all, the basic concept we require when you go for any quicksort method is we require a pivot element. So for our convenience here we are taking the pivot element is first element which is in the first index, that is 40. Now here we require one variable, that is I, and here we require one more, that is j. So what is I value is nothing but the starting index in an array, whereas j value is the last index. And before going to this quicksort method, if there are n number of elements, assume that there exists n plus 1 element. Now here 10 elements are there, no? Just assume there is a 11th element. Okay, no need to take an element here, but let us assume there is a 11th element. Now your j value initially will become that 11. So your j value will become that last index value. So which we assumed that the last value, which is that is n plus 1 value that is existing. Now what we need to do here is initially first you need to increment. So increment I. So I am incrementing I initially, that's why it will become I value 2. Now check out what is a of 2. What is a of 2? 30. Now 30 is less than 40. That is, I am comparing with pivot element. Now whatever a of I value you are getting, that is less than your pivot element. If this condition is satisfied, then increment I. If not satisfied, then stop here, go for j value. So now condition is satisfied. Now I want to increment I value. That I value will become 3. Now what is the value in a of 3? That is 80. So now 80 is less than 40. Is it true? No. Now stop here. Now what is I value? 3. Now coming to the part of j. So here I is incremented. Here it is in reverse. J decrement. Decrement the j value. Now what it becomes? 11 will become 10. Now what is in their index of 10? That is 100. Anyway, here you have checked for less than. No? Here you check for greater than with pivot element. Now 100 is greater than 40. Yes, true. Now what you need to do, if this condition is true, then decrement until it is false. Like next, if you consider what is the next value, a of 9, that is 60. So 60 is greater than 40. Again true. Again decrement j. Now what is a of 8? 20. 20 is greater than 40. No. Now stop here. Now what is j value? 8. Now write I and j values here. So I am writing I value 3 here and j value 8 here. Now check the relation between these two values right now. That is 3 is less than 8. Yes, it is true. If it is true, what you need to do is swap a of 3 with a of 8. What you need to do? A of 3 with a of 8. If this condition is false, Then other thing we need to do, I'll explain when the condition is true. So 3 is less than 8, yes. So now I have to swap a of 3 with a of 8. So here what is a of 3? 80, which will go here 80. Now here it will come, what is it? 20. Now coming to the next part anyway, what is a of 3? 20. 20 is less than 40, yes, true. Now I have to increment I value. Now what is the next value? 90. 90 is less than 40, no, so stop here. So now y value is 4, I will write here. Now j value, in the 8th index I have 80, so 80 is greater than 40, yes, now true. Next I'll go for decrementing of j value, that is 7. What is there in 7? A of 7, 50. 50 is greater than 40. See, all the time I am checking with pivot element, that you need to check out. Yes, true. So again I want to check for, that is decrementing of j value, that is 6. So 70, which is there in a of 6, you can see here. So 70 is greater than 40, yes, true. Again you go for decrementing like this. Now what is a of 5, which is 10, is greater than 40. So now it is false. Now what is j value? 5. So here we got I value as 4, no? Now check out 4 is less than 5, again true. So swap a of 4 with a of 5. So what is a of 4? You can check 90. What is a of 5? 10. So swap here 10, 90. Now what is there in a of 4? 10. Anyway, 10 is less than 40, yes, true. Now I should be incremented as 5. What is there in a of 5? 90. Now 90 is greater than 40, no, stop. Now I value will be 5. Now check for j. What is the j value? 5. What is there in j? 90. 90 is greater than 40, yes, true. Now j should be decremented to 4. Now what is there in 4? 10. 10 is greater than 40, yes, false. So now j value is 4. Now I'll write j value here. Now if you check the condition 5 is less than 4, it is false. So now this process has to be terminated now. That means you need to do, once again I am repeating here, you need to increment I until this condition should be false. That is a of I should be less than a of j, then you need to increment, otherwise stop. Whereas for j it is in reverse, they are incrementing, here you need to decrement. Whereas here you are checking a of I is less than to pivot element, here you are checking a of j is greater than. So like this you need to do, and when you are stopping I and j, then you are checking for I is less than j. If it is true, then you continue with swapping, then again repeat the same thing. Like this, when the condition I is less than j is false, now you need to stop this procedure. After stopping this procedure, what you need to do is, that means you need to check whether I is greater than j. That is I is greater than j. Now this is true. Now what you need to do is, if it is true, swap your pivot element with a of j. I am writing here, swap a of j with v only, that is pivot element, not with a of I. So what is j value now? J value is 4. What is a of 4, which is the element is, which is 10. So v is 40. Now I need to swap these two. So 40 here will become 10, here 10, it will become 40. Now where your pivot element has gone, now you can see, now from this pivot element, if I see the left part, if you observe the left part, what are the elements you have? If you observe 10, 30, 20, of course they are not in the sorted order, but all the elements are less than to your pivot element. Now whatever the elements right side, if you see, that is 90, 70, 50, 86, all the elements are greater than to your pivot element. We need to observe this. So whenever you do like this, okay, whenever you swap with pivot element, the arrangement should be like this. Then this is, we call it as a one pass. After that, now I can say that this total 1, 2, 3 elements are one subarray, this 5 to 10, this is one more subarray. Now these must be individually again has to repeat the same process. That means, let us suppose if I take this subarray, this will be the pivot element, this will be the I value, initial, this is j value. Like this you need to sort, this will become 10, 20, 30. And here maybe this value will be the pivot, and this is a of I value, this is a of j value, and again you need to sort and again do like this. So if you do like this process, finally we'll get an array with sorted elements. So here it will become 10, 20, 30, here it will become like 40, anyway it is there, 50, 60, like this up to 100 you will get it. So this is a procedure which will happen in your quicksort method. So I explained this with an example right now. Now we'll go to the theory part. Yeah. It is a divide and conquer approach that can be used to arrive at an efficient sorting method. In metsort, of course we are here comparing just with metsort. In metsort, the file A of 1 to n was divided at its midpoint into subarrays which were independently sorted and later merged. This point has to be noted here, where you can see this midpoint. Why? Because whereas in quicksort the dividing point may be midpoint, may not be, but whereas in metsort this will be the midpoint. So in our example we have seen already. So 40 we got, that is index is 4. Left side we have only 3 elements, right side we have I think 6 elements. This is not exactly half, so that's what we need to observe. So whereas in metsort it will be divided into almost equal. If there are 10 elements, it will divide into 5, 5. If there are 11, it will divide into 5 and 6, not like 8 and 3. So it will divide equally in metsort. But whereas in quicksort, there is no condition like that. It may or may not. It depends on, of course, pivot element. Now in quicksort, the division into 2 subarrays is made so that the sorted subarrays do not need to be merged later. Why? Because so you are just rearranging the elements. You are not taking an auxiliary array here, where you have taken this auxiliary array in metsort. So here you are not taking any auxiliary array here. You are just simply rearranging the elements in the order. Okay, that is the thing here we need to observe. So this is accomplished by rearranging the elements, that is A of 1 to n. So those elements, how you are rearranging, we have seen the cases. This is A of I is less than or equals A of j for I between 1 to m. That is m means that is somewhat like pivot element, and first next for another half array, like this you are taking. So thus the elements A of 1 to m is the first part and A of m plus, so can be independently sorted. So we have seen that how these things are independently sorted. So no merge is needed. That's what we said. This rearranging is referred as, we call it as partitioning here. Now, so this is a quicksort algorithm. Actually, for the algorithm of quicksort, we need to have 3 procedures totally. The first procedure is quicksort procedure. The second one is a partition, which is a one more procedure, and third one is, if you go to the partitioning method, we have one more procedure, that is interchange. I defined interchange here itself. So total 3 procedures combinedly will get the concept of quicksort. Now we will see what is this quicksort here. So quicksort of P comma Q. So I'll connect this algorithm with our example so that you can understand better. So what is P here? In our example, P is 1, Q is, what is Q? Total number of elements 10 only. So that is the index here we need to take. Sort the elements from A of P to A of Q. That means A of 1 to A of 10, which resides in the global array, that is A of 1 to n, into ascending order. That means, see, A of 1 to n, why we have taken P comma Q and 1 to n means 1 to n is global array. When if we divide it into 2 parts, so then we will actually making 2 subarrays. Now then it will become like, if you take in our example, I'll go with this. Yeah, in our example it is divided into 2 parts. No, so 1 2 3, that means here P value is 1, Q value is 10 initially, but now after dividing, p value will become 1 and q value will become 3 in for this subarray, and for this subarray p value will become 5 and q value will become 10, like this. Here this quicksort procedure is a recursive procedure, so the same procedure is calling itself here. You can see quicksort, the calling itself 2 times here. So that's what. Anyway, now what I said is a of n plus 1 is considered to be defined and must be greater than or equals to all the elements, as I said. No, so if there are 10 elements, I need to assume that 11th element is existing, like that. So if p is less than q, what you need to do is divide the problem into 2 subproblems. That is, you require to find the partitioning element, where I need to partition exactly 2 parts. So in our example, we partitioned at the position of 40. So that's what we need to get here. So how to get? We need to go for the procedure of partition. We'll see that. And one more thing we need to remember. Partition a comma p. What is p value? 1 and q plus 1. So that is 10. That means your partitioning algorithm. So initially, I am talking about initial values. That is an array which consisting initial value 1 and q plus 1, which is 11. So 10 plus 1, which is 11. Now we'll go to partitioning algorithm directly. Here we can see. So what is this? M value, p value. So what is m value? As per our example, initially m value is 1, p value is 11. Now we can see the same thing here. Of course, this is the theory part, and now I am starting here. Okay, this is the theory part. You can understand. Here it is t equals to a of m, means t is nothing but pivot element. So what is t equals to a of 1? What is the value in our example, which is 40, no? Like that. So that is t. Here I said in the algorithm we have taken it as v also. So you can take that is v equals to 40. So I equals to m. That means we have taken I equals to 1 there, and j equals to p. What is p? 11. So this is only we have taken there, and see this repeat inside one more repeat, and 2 repeats actually inside. So repeat I incremented until a of I is greater than or equals to v. So this is a process we have done here for this. So this is incrementing until this condition is, that is less than is false. That means until greater than. The same thing here we have taken. So this is a procedure where we have taken I incremented and until a of I is greater than or equals to v. See, in this same thing, repeat j should be decremented until it is less than. If it is greater than, again increment. Like this you need to do up to what? Up to until, here you can see. This is until what you need to do. See, in the middle you need to check it out. If I is less than j, what we have done? Interchange I comma j. That means in our example, when I have taken here, what is the first one? 3, and here I got 8. So 3 is less than 8. That means if I is less than j, what we are interchanging? Interchanging a comma I comma j. That means interchanging the elements which are there in a of 3 and a of 8. So that's what here we are taking. So it goes to interchange part. That means interchange is a one procedure. See, don't worry about this interchange procedure. It's simply the procedure where it can swap by using temporary variable p. So this is a simple method, simple procedure where you can swap 2 values. That is a of I value into a of j value into a of I, like this. In order to get that, I have used this procedure. Okay. So this process, this repeat has to be repeated until what? I is greater than or equals to j. So in our example, see, we repeated 3 is less than 8, again we repeated 4 is less than 5, again we repeated. But when 5 is less than 4, this is false. What we have done? We stopped swapping with a of I and a of j. What we have done? If it is greater than, we swapped with a of j with v. So that's what we can see here in our algorithm. So until I is greater than or equals to j. That means when this condition is true, what you are doing here, you can see a of m is equals to a of j. So what is a of m? That means a of 1 is equals to a of j. What is a of j? We have taken there, I think 10 we received. And a of j, what is a of j? I think there we have taken a of 4, which is equals to v, which is 40. So like that we receive here in our example. Yes. So a of 1 where it is 10, and here a of 4 which we got 40. So this is the procedure, actually happens. And now what it is returning? 4. What is j value? 4 only, no? So it returns 4. Now thing is, after returning j here, it goes to our procedure. So in the 10th line, now what is the j value we received? 4. Now j is the position of the partitioning element. Exactly. Solve the sub problems. Now we are dividing. When we received the partitioning element, see what we have done here. We require a partitioning element among all the elements. See, in this index I need to separate. Where I need to separate? Actually where I need to partition, I don't know. For this purpose I have done this entire part, and I received the j value. From that I am partitioning it into 2 parts. So now you can see. So quicksort of p. What is p value? 1 initially. J minus 1. What is j? 4. So j value is 4, no? So 4 minus 1. So quicksort of 1 comma 3, and the another one is j plus 1, that is 5 comma q. What is the q value? 10. Now we can see the subarray is 1 2 3, and the one more subarray is 5 to 10. We can see in our example also. So one subarray is 1 2 3, the another subarray is 5 to 10. Now it will be again sorted. So this is the process. That means here, see, this is a recursive procedure. Again it will go for what is p value, means 1, and previously q value is 10. Now q value is 4 minus 1, that is 3. So it will become like, again here p value is 1 and q value is 3 for this 14th line recursive procedure, and for 15th line p value will be 5 and q value will be 10. So like this it will sort recursively applied, and finally we'll get the answer. That is, we can see here we are not writing anything to combine the solution. That is, there is no need for combining the solution. So this is what happens in quicksort method. So this procedure entirely, that the first procedure quicksort, where you require a partitioning element. For that purpose we are going to the procedure partitioning. Here this will gives the answer, returns j value, where j value is nothing but where we need to partition the array into 2 parts. So after getting this, again we are going to here, and from that partitioning you are dividing this and recursively finding. So you are dividing it, and finally solution you are getting. That's why again this is also one of the divide and conquer procedure. Thank you.